Still in 11.2, we're talking about combining power series, and the theorem in the book talks about if you have two power series that you know converge absolutely, you can add them or subtract them. You can multiply them by a power of x, or you can do a composition of them, and they will still converge absolutely. So looking at example 3, it wants us to start with this. K equals 0 to infinity. This is x to the k, which is 1 plus x squared plus x cubed plus dot dot dot, and it works for all x. That's the abbreviation for all x that are less than, I guess I shouldn't write it like that, because of the absolute value, for all x that are less than 1. So between -1 and 1. Part A wants us to come up with this one. It says find a power series and the interval of convergence for this function. So all I have to do is take the summation they gave me and multiply it by x to the 5th. So it's going to be this, dot dot dot, which turns into x to the 5th plus x to the 6th plus x to the 7th plus dot dot dot, which would be the summation k equals 0 to infinity x to the 5 plus k, or k plus 5. Now, the geometric series, this is a geometric series. In this case, the r is going to be x, and when does it converge? When it is less than 1. So our interval is from -1 to 1. Right there is the interval. Part B, they want us to find 1 over 1 minus 2x. Well, all I need to do is take the original series that they gave me and replace every x with 2x. So the list of terms would be 1 plus 2x plus 2x squared plus 2x cubed plus dot dot dot, which would reduce to 1 plus 2x plus 4x squared plus 8x cubed plus dot dot dot, which would turn into the summation k equals 0 to infinity of 2x to the k. All you do is replace the x with a 2x. Now, this also is a geometric series, and in this case, the constant ratio is 2x. So I would have to take the absolute value of that being less than 1, and dividing by a 2, I get this. So the interval of convergence will be from -1/2 to 1/2. Part C, 1 over 1 plus x squared. Okay, so to get from the original statement to the new one, if I substitute a negative x squared in everywhere I see an x, and I'm going up to the top of the paper, right there. So the series is going to turn into 1 plus, I'm going to replace the x with a negative x squared, replace the x with a negative x squared. What did I write? That parentheses on the wrong side. It goes this way. Negative x squared to the 3rd plus dot dot dot. That would be 1 plus negative x squared. So negative 1 minus x squared. That's going to be minus x squared squared. That's going to be plus x to the 4th. And I'm going to have minus x squared cubed be negative x to the 6th, and so on. The summation turns into, I notice it's alternating. I'm starting at 0, so if I have a -1 to the k, the first term will come out positive, and then every x needs to have a 2k, because they're going by even terms. Now, in this case, you've got a geometric series whose ratio is negative x squared, and it will converge if that is less than 1, which then becomes that in less than 1. So in turn, that is x, absolute value of x is less than 1. So there's your interval. The next thing is talking about differentiating and integrating. You can do term-by-term derivatives and term-by-term integrating. So for example 4, They want us to take that same original function as from example 3, and they want us, let's see, we're going to write out what it means. It is x to the k equals 0 to infinity, and it's term by term looked like this, and so on. They want us to differentiate the series term by term to find a power series for the derivative and identify the function it represents. So the first thing I know is the function that this represents, the derivative of this would be, that's 1 minus x to the negative 1, so negative 1 minus x to the negative 2 times the derivative of the junk inside. So the function they're talking about is 1 over 1 minus x squared. So I've identified it. Now I need to do term by term differentiation on this. So if I take the derivatives one at a time, derivative of 1 is 0, x is 1, 2x, 3x, and so on. 3x squared. So what's happening? Do the same thing on the summation. What do? You pull the power in front and you drop it by 1. So when I'm at, term 0, I get 1. When I'm at term, this will be term, I'm not going to use this guy, term 0, term 1, term 2. Notice the term number matches the power, so I know I'm going to have an x to the k. But the number in front is 1 bigger than that, so the number in front is going to be a k plus 1. Now, what's the interval on this? Well, it's the absolute value of x must be less than 1. And so that then tells me that f prime of x, which is 1 minus x to the negative 2, would be equal to this summation. And now if I check the endpoints, if I stuck a negative 1, remember this is a negative 1 to 1 interval. If I stick a negative 1 in there for x, that diverges. I have an alternating 1, negative 1, 1, negative 1. So okay, that's done. If I stick a 1 in there, I just get 1 plus 1 plus 1 plus, okay, that diverges as well. So they both diverge, so I can't include the endpoints. It's just negative 1 to 1, non-inclusive. Part B wants me to integrate. So if I take the function and I integrate, that actually turns into, that's a natural log, but the derivative of 1 minus x is a negative. So it's going to be a negative natural log of 1 minus x plus some constant. And so if I integrate the terms, going back to the original equation and integrate it term by term, integrate 1, you get x. Integrate x, you get 1/2 x squared. Integrate x squared, you get 1/3 x cubed, and so on, plus that c. And so the summation for this one, now this time, since I have to get x, and I kind of like my term numbers to line up with my exponents, I'm going to start it at 1. So I know I need x to the k, and then the fraction in front is the same number, so that's 1 over k. Now, on the interval, again, x has got to be less than 1. So if I check 1, I'm going to get a multiple of the harmonic series. It's going to be 1 over k times negative 1 would be, no, when x is 1. That's a harmonic series. So that's going to diverge. And when x is negative 1, it's actually the alternating harmonic series, a multiple of it. And the alternating harmonic series converges. So my boundaries here would be negative 1 less than or equal to x less than 1. Or in interval notation, negative 1 to 1 with a parenthesis. Remember how you're doing that. You're taking x equals negative 1 and you're plugging it in, so the summation turns into negative 1 to the k over k. It's an alternating harmonic. Excuse me. Negative 1 to the, it's an alternating harmonic, and that converges. Okay, and then if I do x equals 1, I end up with plugging it back into my summation right here. I get 1 over k, which is the harmonic, and that diverges. So that's how you check those endpoints.